When we consider forensic science, it's a highly scientific field, but lesser known field. Not many people enter into forensic science. The definition of forensic science is that it's the use of scientific methods or expertise to investigate crimes or examine evidence that might be presented in a court of law. So the main goal, main objective of forensic science is to find out the evidence and present it in the court of law. So there's a procedure which investigation officer needs to follow. And if the procedure is not followed, then the evidence may not be accepted in the court. Now, mathematics can be used to determine how crimes are committed, when they are committed, and who committed them. So there will be some scenarios. Let's say, for example, if you find a dead body, then we may have to find out when the death has occurred. That is basically to determine the time since death. Then, if you consider the mathematical concepts, so only few concepts are listed here, like measurements, trigonometry, proportions, handling data, probability, distributions. But there can be more complicated and more advanced mathematical concepts that can be used depending on the requirement. Then forensic scientists, they analyze crime scene for possible clues pointing towards suspects and evidence. Then some of the forensic applications which we can consider are lie detection, then determining the time since death, then if it is accident, suicide or a murder when the dead body is found, then calculate the percentage of concentrations, maybe percentage of drugs in the blood, percentage of alcohol in the blood, then compute blood stain thickness, then ricochet analysis and the aspects of ballistics, then DNA analysis, fingerprint analysis, and the list goes on. Now, every forensic investigation process has got these 6 steps. So first one is identification, then collection, validation, examination, preservation, and presentation. In the first step, identification stage, what happens is that investigation officers, they visit the crime location and they entirely seal the crime location. That is because they don't want the tampering of evidence there. And they are going to identify all the objects which they can take it into custody. So there is something called as chain of custody, in which they have to enter the objects they have taken into custody and in what state it was. Now when we come to digital forensics, say for example, if we have to confiscate the laptop or a computer or any computing device, right, we have to confiscate in the present state. For example, if the system is on, we should not turn it off. If the system is on, we should not turn it off, and if it is off, we should not turn it on. That's because there will be some evidence which will be residing in the volatile memory, and if you turn off the system, the information present in the volatile memory will be lost. So what they do is, if there's a desktop, right, so they'll just simply pull the plug and take the system to the lab, so that the information in the volatile memory is preserved, and they can take the snapshot of the entire system for further investigation. And there will be some toy devices. For example, there may be a pen drive which looks like a toy. So such devices may go unnoticed. So they have to very cautiously and carefully identify the objects and take them to their custody. So that's the identification and collection stage. Now, when we are taking the snapshot of a computer for further investigation, right? So what they do is they compute the hash of the original snapshot and the copy of the original data, and they make sure that the hash of both the images or snapshot matches. That is because to maintain the integrity, to prove the integrity in the code, that message or the system or the image has not been modified. The next is the examination stage. So basically in examination stage, they perform examination on the copy of the data so that the original data can be preserved as it is. And when they are performing the examination, there is a possibility that the software which is performing the examination, that it may alter the data. So the forensic softwares should be such that they should not alter the data. So standard softwares needs to be used. There are some criteria for forensic softwares which we will discuss it later. Then preservation. After collection, we have to make sure that all the objects are preserved in a proper place at the right temperature with the right security. And there is a plastic bag called as electrostatic bags, which are also called as Faraday's bags, and in those bags these devices or these objects are put so that the evidence or the objects are not tampered. Then finally the presentation. This is the most important step, because whatever 5 steps we are performing, the goal is to find out the clues, find out the correlation among clues and present it in the court of law. So there is a well-defined procedure which investigation officers needs to perform in the above 5 steps. And if there is some lapse, then it may not be accepted in the court of law. So last step is very, very important. There is something called as Daubert standard. So in United States, the Daubert standard is a rule of evidence regarding the admissibility of expert witness testimony. So there are some illustrative factors which the court has defined and which are part of something called as scientific methodology as a process of formulating hypothesis and then conducting the experiments. So that is to prove or falsify the hypothesis. Now, there are 5 illustrative factors. So these are general illustrative factors, but these can be mapped to programming languages as well. Now the first illustrative factor is that has the technique been tested in actual field conditions and not just in laboratory. Then the second question is, has the technique been subject to peer review and publication? Then what is the known or potential rate of error? Then do standards exist for control of techniques operation? And finally, has the technique been generally accepted within the relevant scientific community? So there is one-to-one mapping between illustrative factors and open source programming languages. Now, in 2003, Brian Carrier published a paper that examined the rules of evidence standards, including the Daubert, and he compared and contrasted the open source and closed source forensic tools. And one of the key conclusions of his study was that using the guidelines of Daubert tests, the open source tools may more clearly and comprehensively meet the guideline requirements than would closed source tools. So if there is a closed source tools, how are you going to perform peer review? Peer review will be within the company, but that is not the acceptable factor. But if you consider any open source software, peer review will be by the community. So there may be multiple companies which are involved. So it creates more trust. So now when we map the previous illustrative factors to the programming languages, right? Especially the open source programming language, it can be Julia, it can be Python, it can be any other open source programming language. So here, again, we have to ask the same illustrative factors with respect to programming language. Now, the question is, can the programmer algorithm be explained? And this explanation should be explained in words and not only in code, because we have to explain the algorithm or the functionality or the source code to people who are from non-computing background. So they may not understand the computing jargon. So we have to make sure that they understand the algorithm, they understand the functionality. Then has enough information been provided such that thorough tests can be developed to test the program? So you need to have many test cases here and make sure that there are less and less problems with the software. Then have error rates been calculated and validated independently? Then has the program been studied and peer reviewed? Now if you consider open source softwares or open source languages, right, you will find the entire source code on GitHub repository. Anybody can go to GitHub repository, read the code, review the code, create the issues, right, and contribute. Then has the program been generally accepted by the community? Now you take Julia or Python, right? So they are already recognized in the scientific community. So they are considered scientific computing languages. Now let's consider some real world problems, right? Now when we say math or when we say these problems, many times it's just a simple math which is helping us to solve the problems. So there are already uh, equations, well established equations are there. We just need to use those equations. Sometimes we may have to modify the equations in order to find out the required issue. Now let's consider these problems one by one. So let's see how to compute the pressure of a shoe print on a soft ground. Now here the measurements are taken of the length of the shoe prints and the depth and how far the prints are. Now if you take the measurements between two footprints, it may give you some estimation about the height of the person. So the taller the person, the longer the feet and stride. Similarly, if the bigger the person, right, then deeper the shoe print because of the weight of the person. Then the formula for determining the pressure in this context will be P is equal to mg by A, where g is approximately 10 milliseconds per square, right? Then m is the body mass and A is the contact area with the surface. Then similarly, the next case will be to determine suicide, accident or a murder. Now if you consider the graph here, right, so there are some lines shown, some dotted lines and solid lines. So basically it tells the distance from the building, right? Now there's something called as launch angle. So if there is accidental fall, the launch angle will be 0 degrees because it's just an accidental fall. Nobody is pushing, or when person is jumping there will be higher launch angle because the person is putting some force. Now with respect to suicide, right, so the launch angle is more, it is between 21 to 38 degrees. Then if it is a murder, then it may be very low, okay, because the person may be just throwing the body or he'll be just pushing. Of course the force will be lesser, launch angle will be lesser compared to suicide here. And this is the formula you can use to determine the y. The next is the famous Pythagoras theorem, so everyone knows about it. So now let's see how Pythagoras theorem can be used. Now there's a problem. So the problem is artifact smuggling. So here there is one incident, it's a hypothetical incident here. So here the authorities have video evidence of a possible suspect in the museum break-in. So the suspect was seen carrying a briefcase measuring 20-inch long and 16-inch high by 3-inch wide. So one of the artifacts stolen was 24-inch long and 2-inch wide. So investigators are trying to determine if the artifact was possibly smuggled out of the museum in this suspect's briefcase. Now according to Pythagoras theorem, so when you apply it on the dimensions of the briefcase, so we'll get 20 square plus 16 square is equal to 656, and the square root of 656 would be 25.6 inch. Then the length represents the widest space of the briefcase. So since it is greater than the length of the artifact, so it is conceivable that the artifact was smuggled out of the museum in the briefcase. Then similarly, there is something called as resolution of human eye. So now when we consider an example of witness statement concerning the identification of an individual, so that is valid given that the suspect was some distance away at the time. So we might have watched in several movies, advocate asks a witness, do you recognize this person? So do you recognize this person? Then the person may lie, but there are techniques which we can use and validate whether the witness is lying or whether the witness is telling the truth. So that is based on the resolution of human eye. But of course here we are not considering any additionals like specs or lenses here, because for that again we may have to change the resolution and apply a different formula. Then the fundamental result underlying this is that the unaided ideal human eye has angular resolution limit of around 1 minute of arc, which is equivalent to 0.0003 radians. So such a resolution limit means that any two distinct features in an object that subtend an angle greater than this will be resolved by the eye. Otherwise, features will merge and appear blurred and indistinct. So, if particular features separated by the dimension d lie at the distance L from the observer, then by the definition of radian, we can require the following condition to hold for the object to be resolvable. So d by L should be greater than 0.0003 radians. Now, consider this problem here. So a witness with perfect eyesight who viewed the suspect from distance 200 meter in daylight claims that he was wearing a striped jumper with the stripes being around 4 centimeter wide. So is this statement scientifically reasonable? So when we put the values in the formula, we get the value of 0.002 radians. So with that we can easily make out. Then next, so if we consider these scenarios, it's all just simple 1 or 2 lines of code which will give you the result, right? You need not have to invest much time in coding also. But that is not true in all the cases. Now there is something called as hash functions. So hash functions are one way encryption functions. So without say for example, so hash functions encrypt the information irrespective of the length of the input, and they generate the fixed length message, right? So the basic goal of hash functions is to prove the integrity of the message, right? So you can compute the hash function using a simple code like this. For example, function simple hash. So pass the input and return the hash. So value to hash will be, I want to compute the hash of the message hello world. Then you can just print the message using simple hash function, and you can see here that it is printing the hash code. Now what we did in this case is that we added an additional space at the end of the message hello world, and this time it has generated a different hash code. So even a smallest or the smallest modification will result into modification of the hash code. So with this we can easily make out whether the message has been modified or whether the integrity has been compromised. Then extracting metadata. So metadata is data about data. That means, for example, we store information in files, but we need information about files. For example, when the file was created, what is the type of the file, right? If we take a picture, what is the GPS location of the picture? So such information is also very useful. So in Julia, you can use the package called as file.io along with other specific packages for different file types to extract the metadata of the files. Now consider this one. So here we are considering few packages. So if you want information about your normal files, say text files, so you can use file.io. If you want to deal with, or you want to get the metadata of image files, then you have to install a package called as ImageMagick. You want to extract the information of metadata of audio files, for example the file type, the bit rate, and other aspects of audio file, then we may have to use audio.io. Then you want the information about metadata information about CSV files. Okay, you can use CSV files package. Then extracting metadata. So we install the package, then we are importing the packages. Now we are setting the files for these uh, files, and then extracting the data using get underscore metadata function or schema function. It depends on the package and which function they have. The next is forensic indexing and searching. So here in Julia, you can perform forensic indexing and searching using light graphs and metagraphs package. So why we need to use forensic indexing and searching? So basically using forensic indexing and searching, we build our own search engine for the evidence which we have collected. For example, if someone confiscates this laptop, there will be terabytes of information on my laptop. So I cannot uh, investigate each and every file. So it is better to create a local search engine on this data. So in this case, such packages will help us to build our own local search engine. Now we can consider using generative AI also. Yeah, so this is how we do it. So we use the packages. Then this is the code. Okay. Then this is the important aspect. So that is called as logging. Okay. So you take any forensic software, logging is an important feature. Okay. Why? Because most of the forensic softwares, they record your activities. Okay. What file you have selected, where you have clicked, what parameters you have selected, and how you have got the output. This is very, very important aspect. Sometimes it is possible for us to get the output using simple Excel also. But in Excel, we cannot record the steps. In court of law, during presentation stage, right, our opposition lawyer, he may simply ask a question, how you have got the output, show the evidence, right? So the one of the important aspect of any scientific package or scientific process is the reproducibility, right? So the opposition lawyer should be able to follow the steps and get the same output. Then he will trust the software. So you have to make use of logging softwares which will record each and every step. How much time I have? Okay. Okay, fine. So I can just take 1 minute and just complete it. Yeah, I'll just wrap up. So similarly, this is a digital forensic scenario where we want to detect the case of money laundering. So this is a money laundering scenario, and you can apply Benford's law and to detect whether there is a possible case of money laundering. Yeah. So conclusion is that forensic investigation is a highly scientific process. So since Julia is scientific computing language and conforms to our standard, it is one of the most suitable languages for developing forensic tools. So in forensics, accuracy of clues and evidence matter rather than the performance of the application. Thank you.
Any questions regarding to the speech? Before that, I have a question actually for you, because I know you own a company. The name is ISEC Cybersecurity. I wonder how you are applying what I've mentioned in the real cases with your company.
So generally what happens is that we get some cases from local investigative agencies, right? So we work with them, and depending on their requirement, we develop a small tools and give it to them.
Are you using Julia there already?
Yes, we are using Julia as well as Python.
Thank you. Any more questions?
I was just wondering about like the lie detection, because that's been a very controversial topic, and how is that translated legally? Is that taken as actual proof that the witness is lying? I don't know.
Yeah, so when you consider all these softwares, so there will be many false positives and false negatives, right? So these softwares will just help us to provide us the clues, right? So again, it is the duty of investigation officers to further collect the evidence and correlate with other pieces of evidence and then take a call. Yeah.
Anyone has a question?
I have another question, sorry.
Sure.
So how is Julia, as you mentioned, there is actually a more suitable language in case of their double standard. How's Julia better than other programming languages in that case?
No, actually, when we discussed the one of the slides where we had discussed Dauber standard and Julia, right? So there is a study done by Mr. Brian, right? So he has concluded in his study that open source languages or open source softwares, they are following the illustrative factors laid out by the code more than the closed source softwares. So it's not only about Julia. You take any open source language, right, which has these illustrative factors, it's better. For example, is Julia peer reviewed and published? Right, it's already there on the GitHub, right? And apart from that, there are many scientific papers which have been published, right, which have validated the work of even Julia language and the packages, right? Then there are many tutorials which explain how the code works. So if you see there clearly, right, and there's a strong community also, right? So all these factors, they make Julia suitable for forensic investigation purpose. So there have been very nice packages in our language also. So if you go to a website called Forensic Stats, right? So you'll find wonderful packages in wonderful packages for forensic science. But the only thing is we don't have them in Julia. So the alternatively, we can take the ideas from there and we can start developing the packages.
Thank you for that,
Yeah.
Gajendra.
Thank you.
Yeah. Let's give another applause for the speech. Thank you for the speech today.